So the complex part is over. In the previous video, we have talked about the theory of how to conduct a mediation analysis, and in this particular video, I'm just going to focus on one example that I'm going to use in the lab, and then I will talk about some of the extensions and some of the softwares and some of the resources at the end of this video. So basically, this was our exposure variable osteoarthritis. Cardiovascular event was our outcome variable, and since pain medication was the mediator, we did not include that when we were trying to get the total effect from osteoarthritis to cardiovascular disease. So we did not really adjust for pain medication in our regression trying to find the total effect. But when we are trying to find the direct effect versus the indirect effect, then we include that pain medication in our DAG, and then we need to figure out a process of finding the direct effect and the indirect effect. Alright, so in the lab, one of the things we do at first is we try to check whether our exposure variable is a significant predictor of the pain medication or not. Since we are trying to justify a mediation analysis, one of the things we need to see whether these variables are at all related or not. If they are not related, I'm not meaning related by saying that you have to have a significant relationship between this odds ratio osteoarthritis and this pain medication, but you have to justify that pain medication is probably something that is mediating parts of the relationship, right? And one way to do that would be to run a regression with mediator variable as the outcome variable, and this age exposure variable would be the osteoarthritis variable, adjusting for all of the other confounders, and whether there is still any relationship between this osteoarthritis and pain medication after adjusting for the confounders, right? So this sounds like one way we could try to justify whether we want to assess this mediation effect in our main analysis or not. However, if this osteoarthritis and mediation has nothing to do with each other, then they are basically independent predictors of the cardiovascular disease. In that sense, whether doing any mediation analysis makes sense or not, that we have to think about. Alright, so when we do mediation analysis, and this is something that we will see in the lab, is that we can estimate the total effect, we can estimate direct effect, indirect effect, proportion mediated. These are the parameters that we will see in the lab. But one of the points that I was making in the earlier video is that since we are duplicating data in the process of getting the direct effect and indirect effect, we need to resort to bootstrap to get our confidence interval or the standard errors correct. So these last two numbers that you are seeing are basically confidence intervals, and interestingly, you can see total effect is significant, direct effect is significant, but the indirect effect was not as significant. So only 8.5% of the effect was being mediated by the pain medication. So does it make sense to do a mediation analysis or not? At least you can now segregate the difference, the effect of the direct effect and the indirect effect, and you can show that even without the pain medication variable, the direct effect is strong enough to justify the relationship between the osteoarthritis and cardiovascular disease, right? So that is some finding. Alright, so now let's talk about what happens in a survey data analysis context, right? So one of the problem that we have seen earlier as well is that in the survey data analysis, we need to incorporate the survey features. When we are at least doing our outcome analysis, we need to address the strata, cluster and weights to make the design, and then we have to do the design. But it is not clear, because similar to our propensity score model, we have two parts of our model. One part is the outcome model that happens at the last step, and one part is the mediation model that happens somewhere in the middle of the mediation step. And it is not really clear in the whether we need to include these survey features in the mediator model, right? So this is some issue that is not really clearly investigated in the literature. So what we did instead, we looked at the propensity score literature, and essentially we came up with the same solution, is that when we are going to do the outcome modeling, we are going to incorporate the weight, but when similar to the propensity score model fitting, when we are doing the mediation analysis or the mediation model, we are basically not using any of the survey features. And this is consistent with the Zunotto's suggestion of the propensity score matching, but in this particular case we are essentially doing weighting, which is slightly different than matching, but we are essentially using the same ideology here, that outcome model should incorporate the survey features so that we can make our prediction about the total population. But for the mediation, we do not really care too much about it, because from the mediation we are basically trying to get some prediction and of the mediator weights, and for that we do not need to be super careful about the standard error in the intermediate step. Alright, so let me talk through some of the assumptions, because as you can imagine, the assumptions for mediation analysis is going to be much more complicated and much more strict, and some of the assumptions we are making for the mediation analysis, you have to justify that in your analysis to when you are doing a mediation analysis in your paper. So the first assumption is, and this is not very different than the propensity score analysis, the first assumption is that there is no unmeasured confounding. And this applies to propensity score, this applies to mediation analysis, and if you have a unmeasured confounding, you have to justify your analysis, because essentially you are losing some variable that would have given you much better association estimates. And the problem with confounding now is that the confounding is not only associated with the outcome model. The exposure outcome association is something that that can be confounded by some confounders. The exposure mediator association, remember a few slides earlier we assessed the relationship between the mediator and exposure controlling for the confounders. That gets impacted when you do not have the measured confounders. Also the mediator outcome association, and this is something that we do not observe directly, but in the process of fitting the direct and indirect effect, there are a couple of times when we are at least in the outcome model, if you remember, there was the A and A star for the direct effect and indirect effect, and in some way the mediator and outcome relationships are being assessed there. So in that case, you will see that you do not only have to think about the exposure outcome association being confounded, you also need to think about exposure mediator association being confounded, mediator outcome association being confounded. So justifying that no unmeasured confounder in this context is much more harder than a regular regression analysis or a propensity score analysis. And of course, I mean, now that you are dealing with more and more models, model specification is a very critical problem in mediation analysis, and you need to consider some realistic or plausible interaction terms that can lead to better model specification. So rest of these assumptions, and these assumptions are also mostly common with the propensity score analysis. The positivity assumption, previously when we were dealing with positivity assumption, we were only considering whether our probability of being exposed given certain characteristics were greater than 0 or not. But for our mediation analysis, we need to consider this extra probability of being mediated given that that person was belonging to certain exposure group and certain confounder group, and that probability being greater than 0 is something that you need to make sure now. Causal consistency, a similar idea as the exposure. If you have multiple version of treatment, then your causal consistency is not there. If you have multiple version of your mediator, that is also creating some problem. So what could be some example of this causal consistencies? Say, for example, in your exposure group, when you are supposed to have only the osteoarthritis patients, if you put some rheumatoid arthritis patients in your exposure group, so in your exposure group you now have this osteoarthritis patients and these rheumatoid arthritis patients. So when you get the treatment effect estimate or the exposure group's estimate of causing the outcome, then what is this odds ratio? How would you interpret this odds ratio? Is this odds ratio belonging to osteoarthritis patients, or is this odds ratio belonging to the rheumatoid arthritis patient, or some sort of average of that, right? So it is not really clear. Same thing goes for the mediator. If you are taking 5 milligram of NSAID and someone else is taking 15 milligram of NSAIDs, so in the end, when you get the odds ratio, what does that odds ratio mean for the indirect effect? Is it like some sort of average of 5 milligram and 15 milligram, or something different? So you need to also be very careful about defining your mediator. If it is 5 milligram, just be consistent and make it 5 milligram for all of the patients. Also, we assume here, and this is something that we do not really take into account in our propensity score model because we don't need to, is that there is no interaction between the exposure and mediator variable. If there is some sort of interaction going on, then this kind of analysis would not really give you the best estimates. Alright, so far we have seen a very preliminary version of mediation analysis, and if you look into the literature, there are many methodological extensions that has been proposed already, and this is an active area of research. Many research has been going on in this mediation area. One example is there are methods that can incorporate more mediators. So for example, when we were considering pain mitigation as one mediator, you can also consider physical activity as another mediator, and you can adjust for both of those in your mediation analysis. In the same analysis, you don't have to do separate analysis for that. You can also think about mediators that are multi-category, that are not just binary, like took pain medication, did not take pain medication. You don't have to stick to that. You can work with multiple categories. Say for example, for physical activity, you can work with active, moderate and inactive category, and there are some methodological extensions of mediation analysis that can handle that. There are some additional extensions of survival analysis, additive and multiplicative effect, marginal and conditional estimates, non-compliance, and there are some additional sensitivity analysis that has been proposed in the methodological context. In our example, when we can use the physical activity in 3 groups, you can still get the total effect, direct effect and indirect effect from this kind of analysis. So for example, in this analysis that I'm showing here, there was no mediation going on with respect to this physical activity, and everything that was going on for the total effect, everything that is going on for the direct effect. That means that there is no effect of the indirect effect anymore, and the proportion mediated was also 0%. So that can happen as well. And I think in a sense, say for example in this case, even though I don't think I'm going to show it in the lab, but this is also an interesting finding that there is nothing going on with the physical activity in terms of this type of mediation. Everything is going on from this direct effect, which is an interesting finding in my opinion. Alright, in terms of software, there are many different softwares that are available. I think particularly Medflex is the software that is very interesting and goes with some of the model extensions that we have seen. There are some other packages like mediation package that gives you the risk difference. There are other packages, MMA. I think this one gives you some of the extensions. G mediate, there are some R code available, not really a package. Last time I checked, there are some SAS and Stata versions of mediation analysis. I think I have seen people work on mediation analysis using SAS, and they have very good documentation on that. So this is kind of a standard method that they use right now. Alright, so I remember at the beginning of these other talks or the other videos, I talked about some of the workshops, and some of these things that I am showing in this lecture are inspired by some of the papers written by some of these authors, and those are very useful resources for understanding mediation analysis. Particularly, I attended this ICB conference in 2019 and then participated in this workshop, and I thought this is just a wonderful workshop to join. There are some additional teaching material in the Lenges website, and that those materials are also useful in understanding some of the coding mechanism that is going on in the mediation analysis. Vanderwally often offers workshop through the Statistical Horizons website, but I think I have attended one of his talks from the joint statistical meetings many years ago. He actually has an entire book written on causal mediation analysis. In terms of the references, especially for the implementation details, I particularly found this paper to be very helpful. Especially look at the supplementary materials. That will be very helpful in your understanding of some of the extensions that I just talked about in this video.